Let us continue hydrogen and its compounds. In that, we are discussing Clark's method. This Clark's method is used for removing temporary hardness. So now we will take the water in which temporary hardness causing salts are present. That is calcium bicarbonate is present. Then magnesium bicarbonate is present. These salts causes temporary hardness to the water. To this, let us add calculated quantity of milk of lime. So we are adding milk of lime. Calculated quantity of milk of lime we are adding. Now this calcium takes carbonate and becomes calcium carbonate. This OH minus takes this H plus and becomes water. So this calcium takes carbonate and becomes calcium carbonate. Calcium carbonate is precipitated here. In this one, magnesium takes hydroxide and becomes magnesium hydroxide precipitate. Calcium takes carbonate and becomes calcium carbonate precipitate. Then what is another substance is obtained? That means now what is the substance is there means HCO3 minus is there and H plus is there. Now this hydrogen, this oxygen becomes water. Now what is the remaining means carbon dioxide gas. How carbon dioxide gas is liberated? That we will see. This H plus is acid. This acid removes carbon dioxide from this. Okay. This acid removes carbon dioxide from this. Therefore, we are getting here water and carbon dioxide. Okay. So these salts are causing temporary hardness. Now, due to addition of milk of lime, these salts are precipitated as calcium carbonate and magnesium hydroxide. Go for filtration. Precipitates will be removed. Now the filtrate contains no salts of this. Filtrate is not containing like this salts. Therefore, the filtrate is called soft water. Okay. Now this method is called Clark's method. In the Clark's method, we have to add calculated quantity of milk of lime. Why we have to add calculated quantity? If we add milk of lime excess, what will happen? If we add milk of lime excess, what will happen? That excess milk of lime will be there in the filtrate. Okay. Now excess milk of lime is present in the water. Okay. If you take milk of lime excess, that is present in the water. The precipitates we have removed. The filtrate contains water, soft water. That soft water contains this excess calcium hydroxide. What this calcium hydroxide does means it will take carbon dioxide from atmospheric air and becomes what in the sense calcium bicarbonate. Calcium bicarbonate, that means water again gets what? Temporary hardness. Water is again getting temporary hardness. Okay, therefore, if we take milk of lime excess, that excess milk of lime present in the soft water, that takes atmospheric carbon dioxide and becomes calcium bicarbonate. It is base, it is acidic oxide. This milk of lime is base, this carbon dioxide is acidic oxide. Now you are getting what in the sense temporary hardness again you are getting. Therefore, in Clark's method, this Clark's method is used for removing temporary hardness. But what is the condition means we have to add calculated quantity of milk of lime. Milk of lime should not be remaining, should not be excess. If milk of lime is excess, again we will get a temporary hardness. Okay, sir. Next method we will see. Now we will go for removing temporary hardness as well as permanent hardness. Those methods we will discuss. So far we have discussed two methods. One is sodium carbonate, that means boiling. Another one is Clark's method. By boiling, we have removed temporary hardness. By Clark's method also, we have removed temporary hardness. Now let us remove both temporary as well as permanent. Both let us remove. For that case, let us add washing soda. Let us add washing soda. Now, we are taking water. The water contains CaCl2 salt. Then MgSO4 salt. Now water contains calcium chloride and magnesium sulfate. Water contains calcium chloride and magnesium sulfate, means the water is having hardness. What hardness is there means permanent hardness is there. Calcium ions, magnesium ions, chloride ions, sulfate ions is there, means permanent hardness. Sir, now let us add washing soda. Washing soda means sodium carbonate. Sodium carbonate we are adding. So what will happen means this calcium takes carbonate and becomes calcium carbonate precipitate. This sodium takes chloride and goes to solution as sodium chloride. Sodium chloride. Now magnesium sulfate with the sodium carbonate. What happens? See, magnesium with the carbonate becomes magnesium carbonate precipitate. Then sodium with the sulfate becomes sodium sulfate. Sodium sulfate goes to solution. Most of the alkali metal salts are quite soluble in water. Okay, so sodium sulfate is soluble in water, sodium chloride also soluble in water. Now we are going for filtration. In filtration, we can remove calcium carbonate and magnesium carbonate. Now we are getting filtrate. In the filtrate, what is there means water is present, sodium chloride is present. Sodium chloride is present in the form of ions like this, Na plus and Cl minus ions. Sodium sulfate present in the form of Na plus ions and sulfate ions. So in the filtrate, what is there means water is present, sodium ions present, chloride ions present, sulfate ions present. Now in the filtrate, hardness causing salts are not present, because hardness causing means what? If we add soap into this, soap should be precipitated. Which will precipitate soap? Calcium ions, magnesium ions, ferrous ions. Those ions are not there. Therefore, this obtained water is called soft water. Okay, this method is called washing soda. By adding washing soda, we have removed, we have precipitated calcium ions, magnesium ions. Okay. Next method is called Colgan method. Next method is Colgan method. Colgan is a commercial name. Colgan is a commercial name. What is the chemical name for colgan? Chemical name is sodium hexametaphosphate. Hexametaphosphate. Sodium hexametaphosphate. This formula is NaPO3 6 times. Sodium hexametaphosphate formula is NaPO3 6 times. This exists in the form of complex. What is that complex? Na2, Na4, PO3 6 times, like this complex. This sodium hexametaphosphate, we can write it as NaPO3 6 times. The sodium hexametaphosphate exists in the form of complex Na2, Na4, PO3 6 times, like this. Sodium hexametaphosphate exists in the form of complex like this. Okay. Now, what is the meaning of complex? That we'll see. The sodium hexametaphosphate, this complex meaning is what? Now I will take this Na2, Na4, PO3 6 times, sodium hexametaphosphate. Now, between the sodium and this phosphate, this metaphosphate, it is called metaphosphate. Between the sodium and the metaphosphate, coordinate bond will be there. Between this sodium and this complex, ionic bond will be there. Therefore, if you dissolve this one in water, it dissociates into ions. This becomes Na plus 2 times. It goes to solution, and anion is what means the complex. The complex is so and so. The complex is so and so. So and so complex will be possible. Okay. So this exists in the form of like this in the aqueous solution. This is complex. This complete one acts as one ion. This complete one acts as one anion. Okay, like this. Now this colgan we got an idea. Now we will take hardness causing water. So calcium ions causing hardness, magnesium ions causing hardness. This water will take. Let us add this colgan into this. This colgan is having like this formula. Na4 PO3 6 times 2 minus. Okay, this colgan we are adding. Na4 PO3 6 times 2 minus. This colgan we have added. So now what we are getting, we'll see. What we are getting means calcium ions and sodium ions are displacing, getting displaced. calcium ions and sodium ions getting displaced. Okay, so sodium ions coming outside, calcium ions going into the complex. So calcium ions go into the complex. Now sodium ions coming out. Sodium ions coming out. So sodium ions and calcium ions getting replaced. Calcium ions entering into the complex, sodium ions coming out from the complex. In the same way here also, magnesium and sodium getting displaced. Magnesium ions enter into the complex, sodium ions coming out. Sodium ions coming out from the complex. Okay, magnesium ions entering into the complex, sodium ions coming out from the complex. Like this possible. Now, the resultant is this. Resultant we need not filter. Now you apply soap into this resultant, we will not get precipitate. Why? Because calcium is not free. Calcium is not free ion. It is not calcium, it is complex ion. Calcium is in complex. Therefore, calcium is not free. So calcium will not precipitate soap. Similarly, magnesium. So if you apply soap, soap will not be precipitated because calcium ions is not free. It is inside the complex. Magnesium ions also not free because it is in the complex. So we can what we can say in the sense the resultant water contains calcium and magnesium, but they are not free. They are in complex form. So this resultant solution, to this if you apply soap, soap is not getting precipitated. Soap is not precipitating. Therefore, the resultant is called soft water, we can say. In this method, calcium has gone into the complex. Therefore, this name is a colgan. Calcium has gone. Calcium has gone. Colgan. Commercial name is given like this. Okay. Next, we will go for a permitted process. We are going for permitted process. This permitted is called artificial zeolite. It is what means artificial zeolite. This artificial zeolite, what is the chemical name? Chemical name is what in the sense it is hydrated sodium aluminum orthosilicate. Sodium aluminum orthosilicate. Hydrated sodium aluminum orthosilicate, we can say. This is permitted is artificial zeolite. This is called a hydrated sodium aluminum orthosilicate, we can say. Its formula Na2 Al2 Si2 Si2O6.XH2. It is a formula. So hydrated sodium aluminum orthosilicate formula is like this. Na2 Al2 Si2O6.XH2. Okay. How to prepare this permitted? How to prepare this artificial zeolite? That we'll see. Now we will take soda ash. Soda ash contains sodium carbonate Na2CO3. It contains sand formula silica SiO2. Alumina is there Al2O3. Alumina Al2O3. On heating, what we are getting in the sense we are getting permitted. Artificial zeolite we are getting. So we are taking soda ash, Na2CO3, sand SiO2, and alumina Al2O3. On heating, what happens means we are getting permitted. We are getting permitted. Okay, sir. This permitted formula what we said Na2 Al2 Si2O6.XH2. Now we will divide this by 2. So we will get what in the sense NaAlSiO3.YH2. Like this we got this permitted. This we will write in the simplest form NaZ. This Na we have written, rest of the part we have written as Z. This permitted formula is like this. Now we will take this permitted. How we will take in the sense we will take a tank like this. Now we have taken a tank. Here permitted is packed. Permitted is packed here. Here what is packed in the sense permitted is packed. How the permitted will be there means like rose red, small pieces it will be there. Like how if compressed rice, boil the rice and compress it, boil the rice and press it, how it will appear. Like that this permitted will appear. In that manner only the size will be there. Like that small particles it will be there. This permitted color will be rose red, like this will be there. This permitted will be packed here. Then you pour the water causing hardness, permanent hardness, water causing temporary hardness as well as permanent hardness. That water you pass it here. So water is flowing into this, water coming like this, water coming like this. Water is percolating through this permitted and coming out like this. Coming out water, let us collect. Coming out water, let us collect. In this water, calcium ions, magnesium ions are not present. Calcium ions, magnesium ions, ferrous ions are not present in this water. Why is it so? What is the reaction? Permitted is NaZ, it is solid. Now, hard water contains calcium ions. Hard water contains calcium ions. Calcium ions and sodium ions getting displaced. Sodium ion comes out, calcium ion enter into this place. So CaZ2 we are getting. Then sodium ion goes to solution. Sodium ion goes to solution. So here water contains calcium ions. The calcium ions settling here in the permitted. What is coming out instead of calcium ion? Sodium ion is coming out. Now this water contains sodium ions, no calcium ions. This water contains calcium ions. Okay. So here calcium ion is present. Here calcium ion is not present. Where it has gone? Calcium ion is settled here as exhausted permitted. It is useful permitted. It is exhausted permitted. Using this permitted, we cannot convert hard water into soft water. Then magnesium ions. How magnesium ions will be replaced? That we'll see. Permitted we are taking. This hard water contains magnesium ions. Now magnesium ions and sodium ions getting displaced. So we are getting permitted now like this. Sodium ions enter into the water. So now the water, this water contains sodium ions. In this water, calcium ions not present and magnesium ions also not present. As time passes, this zeolite becomes, this zeolite formula is NaZ. This becomes what means CaZ2 and MgZ2. At certain time, this permitted completely becomes what means CaZ2 and MgZ2. Now this permitted is useful to convert hard water into soft water? No, because permitted is exhausted. This is called a exhausted permitted because we cannot use this permitted for converting hard water into soft water. So what we have to do? Let us convert back this into NaZ. How to convert back? Now stop passing hard water. Pass sodium chloride aqueous solution. Add sodium chloride aqueous solution. What will happen? You see, if you add sodium chloride aqueous solution, this calcium ions and magnesium ions converting like what we'll see. Now we are adding sodium chloride aqueous solution. Here we are adding sodium chloride aqueous solution. Now we are not adding hard water. Sodium chloride aqueous solution we are adding. Now exhausted permitted we will take. Now what happens means calcium ions and sodium ions getting displaced. So permitted NaZ we are getting. Then calcium ion takes chlorine and becomes calcium chloride aqueous solution. So now what happens? You see, you are passing sodium chloride aqueous solution here. Sodium chloride aqueous solution coming like this, passing through this exhausted permitted. Now this calcium ion and sodium ion getting displaced. Calcium ions and sodium ions getting displaced. What happens means this CaZ2 becomes NaZ, regenerated permitted. Calcium ions taking Cl minus and goes to solution as calcium chloride Now here what is coming means calcium chloride solution is coming, that we will drain out. In the same way, magnesium also becoming MgCl2 and comes out. So if you wash this exhausted permitted, if this exhausted permitted is washed with sodium chloride solution, then it is regenerating and become NaZ, regenerated permitted. Now after converting this into regenerated permitted, stop adding sodium chloride solution here, pass hard water. This hard water we can get as soft water. Okay, this method is called a permitted process. Okay, so in this permitted process, in the resultant water, calcium ions, magnesium ions, ferrous ions will not be present. Therefore, in this resultant water, if you apply soap, soap is not precipitating because no calcium ion. Calcium ions, magnesium ions only precipitating the soap. Those ions not present in the water. Therefore, the resultant water we can call it as soft water, we can say. This resultant water we can say soft water because calcium ions, magnesium ions, ferrous ions are not present. Okay, this method is called permitted method, where this soft water will be used. Where this soft water will be used in the sense, in the industries where soft water is required, there they will use soft water. This soft water they will use. In the thermal power station, in the atomic power station, what they will do in the sense, they will convert water into steam. Water into steam they will convert. So the water into steam they are converting. There they are using this soft water they are using. Soft water, and another water is there. This soft water they are using. Another thing, what in the sense, in order to cool the pipes. Suppose in order to cool the pipes, water will be circulated around that. Water will be encircled around it. Water will be passed, which is encircling the pipe. At that time, soft water will be used. Sir, so where we are using soft water, we got an idea. And better than soft water, another water is there that is used in this thermal power station and atomic power stations. Sir, what is that water? That water is called demineralized water or deionized water. How to prepare that water, that we will see. Now we are taking what in the sense, demineralized water. Demineralized water. Demineralized water means, D means no, nothing. What is nothing? Minerals are nothing. That means in this water, minerals are not at all present. Minerals, sodium ions, chloride ions, calcium ions, sulfate ions, like this, no cations, no anions. None of the cations present, none of the anions present, no minerals present. Nothing minerals present, only water molecules present. This is called demineralized water or distilled water. So, how to prepare this distilled water, that we will see. Okay, this distilled water, where it is used? Mainly in the thermal power station and atomic power station, water will be converted into steam. There, this demineralized water is used, not ordinary water. Even soft water also not used. Demineralized water is used in the thermal power station to convert water into steam. Okay, so demineralized water, where it is used, we know. You know that distilled water in car batteries and all we are using, that you know that. Okay, in the lead storage battery in the sense, in the inverter is connected to the battery, no, lead storage battery. In the lead storage battery and all we are using distilled water. That is also just like demineralized water, no minerals will be there. Sir, how to prepare this one we will see. For this we are taking what method in the sense, ion exchange method we are taking. Ion exchange method. In this ion exchange method we are using resin. We are using, what is resin? It is nothing but a organic compound. This resin is nothing but what in the sense, organic compound. Sir, this organic compound, which organic compounds we are using in the sense, one is carboxylic acid, COOH. Another one is sulfonic acid, SO3H. Sulfonic acid we are using. Next one is ammonium hydroxide, ammonium hydroxide we are using. Ammonium hydroxide we are using. These resins we are using. These are organic compounds. Okay. In these resins, two types are there. One is called cation exchange resin. Another one is called anion exchange resin. Cation exchange resin means what it will do means it will remove the cations present in the water except H plus. What it will do means it will remove what are the cations present in the water. All the cations it will remove except H plus. This is anion exchange resin. What it will do means it will remove all the anions present in the water except OH minus. That means this resin removes all the cations. This resin removes all the anions. Then in the resultant water, will there be any cations? No, except H plus. Will there be any anions? No, except OH minus. In the resultant water, what will be there means just water molecules, H plus ions, OH minus ions. That's all. No more cations, no more anions. Therefore, the resultant water is called what? Demineralized water or distilled water. This demineralized water mainly used in which cases? In the sense in the boilers and all it will be used. Boilers means what? To convert water into steam. In the boilers, in the industries, in the boilers, this demineralized water will be used. Why we have to use demineralized water in the boilers? Because if you suppose if you boil ordinary water in the vessel, then pour out the water. So inside the vessel, you see white coating will be there. Like that, boilers also, in boilers, if you use groundwater, salts and all will deposit and white coating will be appearing. No? Then boiler will be wasted. Therefore, only demineralized water will be used in the boilers in the industries. Sorry. Now we will see about this cation exchange resin. How this plant will be there. This ion exchange method plant will be there in the industries. Okay. And now one drum will be there. A big drum will be there like this. One big drum like this it is there. In this, what is packed in the sense cation exchange resin is packed here. Cation exchange resin will be packed. It is nothing but a big drum. Here one inlet will be there. Here we have to pass what in the sense hot water we have to pass. This hot water is passing through cation exchange resin. While what will happen? Which is cation exchange resin means RCOOH. This will take cations in the water. Cations what? Calcium ions. So what happens means here H plus ions and here calcium ions getting replaced. H plus ion coming out, calcium ions entering into this place. Therefore, you are getting RCOO minus 2 times taking calcium becomes solid. Then this is solid. This resin is solid. H plus goes into the solution. H plus goes into the solution. Okay. Similarly, magnesium. In the place of calcium, we can write magnesium. We can write ferrous like this. We can write. So now the coming out water, will it contain calcium ion? No. Will it contain magnesium ion? No. Then what you have to do means like this cation exchange resin, many drums will be there like this, many drums. Same drum again here, same drum again here, like 2-3 times will be there. This water again we have to pass into neighboring cation exchange resin. If any calcium and magnesium ions escaping and coming out, that will caught by neighboring cation exchange resin. Then coming out water again passed into another cation exchange resin. Like this, the water is continuously passed into multiple cation exchange resins, such that in the resultant water, calcium ions and magnesium ions, sodium ions, no cations will be present except H plus. Even sodium ions also not present. Okay, nothing cations present except H plus. So that only how many cation exchange resin drums they are keeping? Many drums they are keeping, not only one. First year hot water is passed into this cation exchange resin. Water is percolating through this cation exchange resin. The coming out water is passed into neighboring cation exchange resin. The coming out water is passed into neighboring cation exchange resin like this. Then in the cation exchange resin, what happens? Cation exchange resin formula is what? RCOH. Here H plus and calcium ions are getting replaced. H plus goes to water, calcium ions enter into resin. This is called a exhausted resin. Sorry. Now cation exchange resin is over. Now water came out from the cation exchange resin. Now water is not containing cations except H plus. In the water, cation means only H plus, no other cations. Okay. Now the water is taken to next drum. Next drum is what means anion exchange resin. Now water is taken into anion exchange resin. Here what is packed means anion exchange resin is packed. Anion exchange resin is packed. Now the resultant water from cation exchange resin is passed through anion exchange resin. What is happening? That we'll see. Now what happens means now water enters into the resultant water from cation exchange resin enters into this anion exchange resin and percolating through this. Now what is happening here? That we'll see. Anion exchange resin formula is what means RNH3 plus OH minus. Okay, anion exchange resin. Now suppose anion present in the water is Cl minus. What happens means OH minus and Cl minus getting replaced. Therefore, you are getting RNH3 plus Cl minus. OH minus goes into the solution. Suppose here sulfate is there. Water contains sulfate means in this place sulfate will come. That sulfate means now sulfate is having 2 minus charge. Therefore, take RNH3 plus 2 times. Like this it will become. OH minus goes to water. So now the water from cation exchange resin contains cation H plus only. This water is passed through anion exchange resin. Now the coming out water contains what means H2O molecules. Only one cation present, that is H plus. Only one anion present, that is OH minus. That's all. In the coming out water, like this equilibrium is possible. Like this equilibrium is possible. At 25 degrees Celsius, this concentration is 10 power minus 7 molar. This concentration is 10 power minus 7 molar. Now the coming out water contains none of the minerals. Sodium chloride, calcium chloride, magnesium sulfate, no minerals present in the water. Therefore, this water is called demineralized water, distilled water. Okay. Now, after certain time, what happens means this cation exchange resin getting exhausted. That means RCOH completely becoming RCO twice Ca. In the cation exchange resin RCOH, instead of that we can take even RSO3H also we can take. Then anion exchange resin RNH3 plus OH minus completely exhausting after some time, becoming RNH3 plus Cl minus or RNH3 plus twice SO4 2 minus, like this. So after some time what happens means cation exchange resin getting exhausted, anion exchange resin also getting exhausted. So now you stop passing hot water. Stop passing hot water. Set. Next what we have to do? We have stopped passing hot water. Now regenerate this exhausted cation exchange resin into regenerated resin. Convert this into like this resin. How to convert this into this? What we have to remove here? Calcium ions. What we have to add? H plus ions. So add dilute sulfuric acid. So you are adding dilute sulfuric acid. What happens means this H plus replaces this calcium ions. Therefore, what happens means now instead of dilute sulfuric acid, better we can add a dilute HCl. Dilute HCl is better. Why dilute HCl better? In the sense calcium sulfate may precipitate. Therefore, dilute HCl, you add it, H plus comes to this place, calcium ion goes to solution, so that it is converting back into like this. So calcium ion will be drained out. Calcium ion comes to solution, will be drained out. Then here, this into like this. How to do? How to do like this means dilute sodium hydroxide solution, you add it. You are adding dilute sodium hydroxide solution. So Cl minus goes to solution. In this place, OH minus comes. So resin is exhausted. We have exhausted resin. We have converted into regenerated resin. So we regenerated the useful resin. Okay. So by adding sodium hydroxide, this we have converted into RNH3 plus OH minus. Cl minus goes to solution, will be taken out. So that now we have got back the regenerated resins. We have got regenerated resins we got. Now you pass hot water, we will get demineralized water. This method is called ion exchange method because ions are exchanging. Therefore, this method is called a ion exchange method, we can say. Next, we can go for a chelating method. Next, we are going for what? In the sense chelating method. This chelating method is used for removing what? In the sense hardness. How it is used? In the sense here we are using what? In the sense EDTA we are using. We are using EDTA, ethylene diamine tetraacetate. This EDTA we are using in order to remove calcium ions and magnesium ions. Now we will take EDTA. We will take hot water. Hot water contains calcium ions. How this EDTA removes this calcium ions, that we'll see. Now first we'll see EDTA. EDTA means ethylene. So we'll take ethylene. Diamine. So diamine. Tetraacetate. Acetate. One acetate. Next acetate. We'll take next acetate. Next acetate. Next acetate. Okay. Now this is EDTA. Now we'll take calcium ion present in the aqueous solution. EDTA takes calcium ion. EDTA takes calcium ion, and what happens means it is making dative bond. Every nitrogen making dative bond, O minus making dative bond. So it becomes complex. Complex is produced. So now it is a complex. This complex we can write it as Ca, EDTA. Now for this 4 minus net charge, for this plus 2, therefore net charge is 2 minus. It is a complex is formed. Now calcium ion is not free, it is in the complex. Since it is not free, soap is not getting precipitated. Therefore resultant is soft water. Here we have taken hard water. Hard water contains calcium ions. To this you are adding EDTA. Calcium ion entering into the complex like this. Now calcium ion is in the complex. Calcium ion is not free. Therefore, the water cannot precipitate soap. Therefore, water is soft water. Okay, this method is called a chelating method. This complex is called chelate complex. This complex is chelate complex, so that it is called chelating method. Okay, so in this way we can remove hardness. Okay, that's all about hardness of water. In the next class we will discuss about degree of hardness and the disadvantages of hardness, that we will discuss.